Optimization and tuning of RAG pipeline is not an easy job. That is why I became quite excited when I saw the headline of this paper, which is AutoRAG HP. HP is for hyperparameter, and then the detail is around automatic online hyperparameter tuning for RAG. Unfortunately, there is no code available, there is no way I would be able to install it, but the details which they have shared in the paper seems quite realistic. So let's see what exactly this paper is talking about. This research is inspired by traditional AutoML practices designed to simplify and automate machine learning AI development. And that is where they have introduced this AutoRAG HP framework. This framework addresses the critical need for efficient and effortless hyperparameter tuning within the retrieval augmented generation systems in the context of large language models. To address these challenges posed by extensive research spaces and the need for online tuning, they have formulated hyperparameter selection in RAG as a multi-arm bandwidth problem and introduced a novel two-level hierarchical upper confidence bound or higher UCB method for efficient parameter space exploration. If you are not aware of multi-armed bandit problem, it is quite an interesting, and it's a classical machine learning decision making problem where an agent must select one arm for or action from a set of arms or actions in each round. Each arm or action is associated with a reward distribution, and the goal is to maximize the cumulative reward over time. Multiple arms means multiple actions. So always in the multi-arm bandit problem, there are multiple actions to choose from. And bandit refers to the fact that the agent only receives feedback or reward for the chosen arm, not for the other arms. And decisions are made sequentially with the goal of maximizing cumulative rewards over time. Also, the thing is that in all of these machine learning systems, RAG has become a real thing when it comes to production environments. And in the process of developing ML AI solutions, AutoML has streamlined automation across three key areas: feature engineering, model construction, and hyperparameter optimization. Over the last few years, AutoML has achieved remarkable success with heavily utilized open source frameworks like AutoSklearn, and then there are various other AutoKeras, AutoPyTorch, and then we have that Flamel, which I already have covered on the channel. But with the emergence of LLMs, a notable shift has occurred where LLMs are frequently chosen as base models, bypassing the traditional model design and training stages. And that is where this research comes very handy, because not only they have formulated the hyperparameter tuning problem in RAG as a multi-arm bandit or map problem, they have drawn an analogy from the scenario of players selecting from a slot machine with multiple arms in a casino. And you really have to read through the paper. It is very, very interestingly written. Look at this diagram, for example. So the player's objective is to choose the arm that offers the highest expected gain. Each time the player pulls an arm and receives a gain or not, they update their estimation of the arm's potential gain. The map problem involves making sequential decisions requiring the agent to balance the exploration of different arms to learn their reward probabilities and exploitation of arms that are expected to yield higher rewards based on the past observation. Given that MAB is an online learning method, it is well suited for the online setting of AutoRAG HP. So on the screen you can see it's a RAG system with tunable hyperparameters, and this comprises a retrieval module, a prompt compression module, and a prompt construction module that assembles the final prompt sent to LLMs for answer generation. And there are a lot of mathematical equations which are involved in it. I'm not going to go into that detail. And then have a quick look at this exam diagram. Let me make it slightly shorter to so that it will fit on the screen. Now if you look here, what is happening here is that they have given an example of two level hierarchical map. So in summary, the objective of map is to maximize the total reward over a series of selections, even when the probability distribution of rewards for each arm is unknown. After a number of trials, the arm with the highest cumulative reward becomes the desired RAG hyperparameter. This approach is quite suitable for cold start problems where prior estimation of user data is unavailable, and leveraging the map framework enables rapid tuning of hyperparameters in the RAG pipeline. So all in all, seems really interesting project, and as I said, there is no way I could really check this out and show you the demo, but I will be keeping an eye on this code repo which they have shared on their main page, and they said that code is coming. So once the code is here, we will try it out again. But they have shown in their paper that their experiments on simultaneously tuning three hyperparameters demonstrate that multi-armed bandit-based online learning methods can achieve the recall at 5 around zero point 0.8 for scenarios with prominent gradient in search space. So that promising result motivates really further exploration into the automatic tuning of rack system, because that is what we needed. Manual tuning is not for us mere models. Anyway, that's it guys. I'm going to drop the link to this paper in video description. Let me know what do you think. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.